Welcome to the demonstration of the programming language that we have developed. We have named it as JDI programming language, that stands for Just Do It programming language. So we are Team 21. I am Ishan Kumar Sarangi.
Hi, this is Sabyasachi Kirti.
Hi, I'm Kumar.
So the key features of our language is it supports numbers which can have digits from 0 to 9. We can have identifiers which can have uh, small letter characters and capital letter characters. We support int and boolean data types. In conditional constructs, we support if else statements, and we also have while loops. Some other features which we have included is like assignment statements and declaration statements. So a user can create integer and boolean data types and can assign their values to them using equal operator. They can also have conditional operators like equal to, greater than, less than, greater than, equal to, and so on. We also have arithmetic operators like addition, subtraction, multiplication, and division, along with logical operators like not and or. So the basic language design flow is when a GDI code has been created, it is passed to the compiler where the lexer tokenizes the code and creates tokens, and these tokens are passed to the parser which creates a parse tree, and this parse tree is then converted into the intermediate code which is in our language. It generates the .igdi file, and then it is executed in the runtime which generates the output. So we have used Antler and Java as our language to generate this language, and we are using a top-down parser to generate the parse tree.
Hi, I'm Kumar and I'll take you through the compiler code which is used to generate the intermediate code from the high level language. Now, for this, we are using AntlerJar to build the Alexa and the parser from the grammar. Now, we'll just take a quick look into the grammar now. This is the grammar. It has the statement which has assignment statement, declaration statement, print statement. The compound statements include the while statement, if else statement, and we have logical operations, conditions, and expressions with addition, subtraction, multiplication, and division. We only accept number and boolean data types for now. So we'll quickly go and build the parser and the Alexa. So for that, we'll be running the Antler jar. This will create the Alexa and the parser and the base listener classes. So we can see the Alexa parser base listener class, and the listener interface has been created. The base listener class has all the helper functions, handler functions for the tokens that will be created. Now, if we move into the code, this will be the high level code that I'll be using for demonstration. Now, for the main class, uh, this is the main class. This takes a file, and then we get the character stream from the file, pass it to the Alexa, which builds the tokenized stream. Now the tokenized stream is passed to the parser, and the parser initializes the base listener, and the listener functions are created as and when the tokens are encountered. So for this program, we're just printing 1 to 9 in a loop, while loop. So if we go into the base listener, we see this is the while statement. It has this is the exit of the while statement. It has a jump loop head. This loop head is defined when we enter the while statement. The loop head denotes the start of the loop, and jump loop head is the uh, iteration for that loop, and label is the line we are calling when the condition is not satisfied. So If we just let's debug one and see. I'll just do a quick debug. And so the first statement here is a declaration of an integer named I, and that's why it has moved into the exit declaration statement function. In this, we get the text, so we'll be printing the text. So INTI is the text that's coming in, and then we get the identifier from this and uh, uh, creator. So the string builder will have declare int, that means it's declaring integer with the name I. Now this is this moves into the second part, that where we are setting I as 10. So it's into the factor. Now if we pass the factor, this is the factor is getting the value 0. So we'll be initializing I as 0 now. Once I is initialized 0, we'll be moving into the while loop. So the factor will be 10 and the relation will be less than, so we'll be printing LT. So if we see the string builder, we already set I, push 10, and this is the relational operator here. So if we run the file to the end, we'll be getting the parse tree here. Now the parse tree, let's just take it to it. This is the parse tree that has been generated by the code. Now if we look into the intermediate code that has been generated, just have to go into here, compiler, JDI, and this is the file that has been created with the extension JDI. Now this we have declared the integer as I, pushed 0, set i's value as 0. Then we have made the relational the condition here with I less than 10, and if the condition unsatisfies, then it will go out of the loop. There's nothing that we're doing out of the loop. This is the jump loop head, which will move to the start of the loop again, and we are incrementing I, setting I, and printing I. So this is what the program is doing. Now, if we take another high-level program here, there are two values that are declared here, and four more, which we are using to store the uh, results. And we are initializing A and B. We're doing sum, product, difference, and divide here, and then we are printing all the values. So if we look at the intermediate code that will be generated for this, it'll look something like this, where we are declaring to variables, setting value to them. Then we are adding the values and setting the values to sum, and the same way to product, difference, and divide. So this is the intermediate code that has been generated, and this was the code walkthrough of the compiler.
So now I'm going to explain how the arithmetic operation works in our language. First, I'm going to the higher level languages, which is in .jdi format. So this is our high level language in which we have declared integer a, b, product, sum, difference, and divide. And we have initialized a to 20 and b to 10. And we are adding a to b and storing it in the value of sum. Similar wise for product, difference, divide, and printing the sum, difference, product, divide variables. So now I'm going to create the IJDI file through our compiler. So this is our IJDI file. Declare int a means a variable a is declared in our map with the value of 0. Similar for decline B, product, sum, difference, and divide. So when we write push 20 means that a value of 20 is stored in the top of the stack. Set A means the top value of the stack is popped and the value 20 is put in in the key A. Similar for set B, the value 10 is put in the key B. Uh, so when we again push A and B into our stack, so in add statement, the top two values of the stack is popped again, and this command will add these value and again push it to the top of the stack. So and set sum will take the pop the top value of from our stack and it will put in the into the key sum. Similar will happen for the mult, subtract, and division. And then when the print sum statement is run, so if the value is boolean, it will convert into true or false. Otherwise, it will print as it will print the value of sum.
I'm going to demonstrate how a while loop works in our language. So, going to our code. So, our program has uh, the start block and the stop block, which denotes the starting and ending of the program, and then we have declared an integer I, and then we initialize it to 0. Then I have a while loop that runs from 0 through 10. On each iteration of the loop, it basically increments the counter and prints it on the screen. So now I'm gonna show you how to generate an intermediate code from the source code using the compiler which we developed. So this is the command to generate the intermediate language. Basically, you need to provide the uh, file which is passed as an argument to the executable jar. So it prints the pass tree once it completes generating the intermediate code. Now, if we see our intermediate code would have got generated. So this is how a while loop works. So whenever it sees a loop head push and a variable in the code, what it does is it'll basically push the value of I onto the stack, and then in the second line you have push 10. So it pushes 10 onto the stack as well, and then you have some kind of a relational operator which pops top two frames of the stack and then evaluates it to true or false. And then whenever it sees a jump if false, uh, yeah. So whenever it sees a jump if false, it'll pop the top frame of the stack and check the value if it's a true or false. If it's a true, then it'll execute the then part of the if, I mean the while, or it exits out of the while loop. So so in our case, I was 0, and we were comparing if I was less than 10. So that evaluates to true. So we'll go inside, I mean, the execution will go inside the while loop. So inside the while loop, we are pushing I and 1 onto the stack, and then we are performing an add operation which pops top two frames of from the stack, and it's setting the value to I. So it's actually incrementing I value with 1 every time the loop executes, and then it's printing I as well. So so when you encounter a jump loop head, so it'll basically increment the counter of the loop, um, which is I from the first statement in the loop construct. So it will increment the value of I and then goes back to the first step, which in the code is implemented using recursion. It's calling the same function again the with incrementing the loop variable. So that's all about the implementation and working of runtime environment for a while loop. I'm going to demonstrate the execution of if statement. So I'm going to the code. So we have declared three variables A, B, C, and A and B has the values of 10 and 20 respectively. So the if-else construct is checking if A is equal to B, then it's gonna print A, or else it'll print B. So that's the code. So once we compile the code, the intermediate code which we are gonna get is this, where the declarations are substituted with declint, and then our initializations are substituted with a push and a set statements. Uh, so whenever it encounters if the condition construct of an if, it will push the expression onto the stack A and B, and then it pushes the equal sign into the intermediate code. So I'm going to generate the intermediate code from our high level code using our compiler. So you can see the intermediate code is generated now. So this is the code that gets generated. Here we can see the condition A equal to B is first pushed onto the stack, and whenever the interpreter encounters a equal symbol, it pops two stack frames from the stack and checks for equality. If they're equal, then it's going to print A, or else it's going to jump out of the if block and goes inside the else, where it prints B. So I'll execute the IJDI file using our interpreter to see what we get. So that's 20 because A wasn't equal to B. So if else condition got satisfied, and it printed B on the screen.
Now I'll demonstrate the Boolean constructs with if. So we'll just take a look into the high level code here. So we're defining a Boolean variable A and another variable as B. We're assigning true and false to them, and we're checking if both are true, then we'll print A, and if one of them or any one of them is false or both are false, we'll print B. So let's just compile the code, and this will compile the code. We see the pass tree has been generated. Now let's take a look at the compiled code, intermediate code. So this is the intermediate code that has been created. The declarations are at the top. We're pushing true into A and false into B, and then we are checking if both are true, then we'll be printing A, and if the condition isn't satisfied, we'll be printing B. So let's just run it and see what's the output. So it's false because the condition won't satisfy, as we have assigned true to one variable and false to another variable. So this is the demonstration of the Boolean construct with if.